Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 970. Please turn to it. Page 970, and today is our lesson number 145. The last three problems in this section, number 18, 19 and 20. These are not easy questions, obviously, on a scale of 1 through 20. These are 18, 19 and 20. Let's take a look at number 18. We're given a picture here. We are told that this line goes through the origin and it goes through point A and it goes through point B. We are also told one more point that it goes through, which is 4 and 10. And the question simply is, in the picture that is given to us, if the legs of the triangle ABC are parallel to the axis, in other words, this leg is parallel to this one, x-axis, and this leg here is parallel to y-axis, which of course it is because it makes a 90-degree angle. So if this is parallel, then this would have to be parallel also because of the fact that it makes a 90-degree angle. Excuse me. It's a right angle triangle. If the legs of the triangle ABC are parallel to the axis, which of the following could be the length of the sides of the triangle ABC? So among the 5 choices that are given, our job is to find the one that is possible, and of course the other 4 that they give you are not possible. How are we going to go about it? Somehow we have to establish the ratio of this side here and this side here. This side, as you can tell, if we were measuring slope of the line, if we were measuring the slope of this line with points A and B and nothing else, if we were to measure the slope of the line from point A to point B, this part is what is known as the rise, and this part is what is known as the run. So somehow we have to establish the ratio of these two sides, which is same as saying we have to figure out its slope, and then look for the combination which has the same slope or same ratio of the two sides as the one that we find from A to B, because slope is going to stay the same throughout the line. And the way we're going to figure out this ratio of the vertical distance to the horizontal distance is by using point 0 here, point O rather, not 0, point O, and let's give this point a name. Let's call it C. So let's figure out the slope of this line using the origin and point C. Point C, of course, using the origin and point C, which of course is 4 and 10, and the origin of course is 0, 0. So let's do it. Slope equals to change in y over change in x. If we go from origin to point C, of course the change in y is 10, because if we go from 0 to 10, that's pretty straightforward. And change in x would be from 0 to 4. The x coordinate of point C is 4, x coordinate of this point of course is 0, 0, so the change in x is 4. So there you go, that's our slope. 5 over 2 is our slope. In other words, the ratio of the rise to run has to be 5 over 2. If this rise is 5, then this run would have to be 2. They have to be in that ratio. That's it, we're almost done. Let's look at the answer choices now. I need the room, so we have to get rid of all of this thing because we need the room. Or perhaps we can continue here. Let's look at answer choice E. In answer choice E, they give us 4, 5 and root 41. This is our x coordinate, and here this is our y coordinate. This is x and this is y. This is our x they're giving us the 4 legs here. They're telling us which of the following could be the possible, which of the following could be the length of the sides of the triangle ABC. So the short one here is 4, then 5. The ratio here is 4 to 5. We're looking for the ratio of the shorter side to the longer side, or longer side to longer side to shorter side is 5 to 2. Here we have 5 to 4. Here we have 5 to 4. That won't do. It's not the right ratio. The third side, of course, is the hypotenuse, which is the longest side, which we'll come to in a second. Let's not worry about the hypotenuse. Let's first find the right combination of the legs. Let's look at D. D says 3, 4, and 5. No, that's not the ratio here. We're looking at 5 to 2. This one is 4 to 4 to 3. This one is 4 to 3. This is our Y. This is our X. This is our Y. When I say X and Y, I'm talking about the rise and the run. This won't do it. 4 to 3. We're looking for 5 over 2, or 2 to 5 if you want to look at the shorter distance first. The ratio of the shorter side to the longer side is 2 to 5. Let's look at C. C is 3 and 3. That's 3 to 3. This ratio is 1. This won't do it. C is describing situations where we are dealing with an isosceles triangle. That's clearly not the case here. This is clearly not an isosceles triangle, as you can see. Next, then we have B. B says 2, 5, and 7. Well, that is right. 5 over 2. 5 over 2. You see, the ratio of shorter side to longer side is 2 to 5, or 5 over 2. So that seems like a right answer. So if you put 2 here and if you put 5 here, what's going to be the hypotenuse? Is the hypotenuse going to be 7? Is it possible for a hypotenuse to be 7 if the two sides are 2 and 5? The answer is no. How do we know that very quickly without doing any work? Because the sum of the two sides in any triangle, one more time, the sum of the two sides, SUM, sum of any two sides in a triangle has to be more than a third side. This could not possibly be 7, because had it been 7, had this been 7, what you're telling me is that I have two options. I can drive from point A to point, let's call it point D here, let's call this thing point D. What you're telling me is that I have two options. I can drive from point A to point D, I will drive 2 miles, and then I can go from point D to point B, and if I did that I will drive 5 miles. I can do that and get to point B, or what you're telling me is that, or I can go straight from A to B and still drive 7 miles. No, that's insane. A direct distance from A to B cannot be 7 miles. It has to be less than 7. It has to be less than 7. Because this is, you told me, is 2 miles and this is 5 miles. The direct distance from A to B has to be less than the sum of the other two sides, which is same as saying what we just said a little while ago, which is that the sum of any two sides in a triangle has to be more than the third side. So B won't do it. B won't do it. The answer is A. The answer is A, because A says 2, 5 and square root of 29. 2, 5 and square root of 29. Let's see if it makes sense here. Okay. If this is the hypotenuse, then the hypotenuse square would be 2 squared plus 5 squared, and 2 squared is 4, 5 squared is 25, and that gives us 29, which is the hypotenuse square, and therefore the hypotenuse will be the square root of 29, which is exactly what we find here. You see? The answer is A. Let's move on to 19. Number 19. We're done with this one? In number 19, we are given a function here that looks something like this. F of x, we are told, is 2x minus 1. And the question is, what's the value of half times f of square root of t? We are told is 4. What's the value of t? Well, let's find out, shall we? If this is our function, then f of square root of t, is where we replace wherever we see x, we replace with the square root of t, and that will be 2 times the square root of t minus 1. So that part was very simple. Then we have to take a half of it. So let's do that. Multiply this side by half, and if we do that, we have to multiply this side by half. That part is done. And we are told that when we do that, it equals 4. So that's what we're going to do. We're going to equate it. We're going to equate this quantity to 4. And now all we have to do is solve for this equation, solve for t. So let's do that. So we have 2 times root 2 minus 1 times half of that equals 4. Multiply both sides by 2 and we can get rid of this 2. And 2 times root t minus 1 equals 8. Add 1 to both sides. This drops out and we end up with 2 square root of 2t equals 9, which means square root of t equals 9 over 2. And that implies that t, if we take the square of both sides, that implies that t must equal 81 over 4. That's it, that's our answer, 81 over 4. That's answer choice. That's answer choice E. Let's move on to the next one, the last one on the page, number 20. Number 20. In number 20 we are told that k is a positive integer. K is a positive integer, and we are told, and we are being asked which of the following must represent an even integer. We are looking for an even integer. We are looking for an even integer that we are told is twice the value of an odd integer. An even integer that is twice the value of an odd integer. Strange. We are looking for an even integer that is twice the value of an odd integer. That's what we are looking for. Now listen carefully. There are two ways we can go about solving this problem. One is what I would call the traditional way, the orthodox way, the classical way, the algebraic way, the academic way, the geeky way, the nerdy way, the proper way. Another way is just a quick and dirty way where we just make up numbers and see what happens. And we have to ask ourselves, what are the possible scenarios here? What are the different scenarios that we have to contemplate? Well, that's very straightforward. All we are told is that this is a positive integer. If it's a positive integer, there are only two possibilities. If we are told that something is a positive integer, there are only two possibilities. It is going to be either odd or even. All we have to do is contemplate both of these scenarios and see which one works out. Let's do it, shall we? Let's do it. Let's pretend that this t is, what do you want to plug in? It's up to you. Let's pretend this t is, it's up to you, what do you want to plug in? Well, it has to be odd, so you might be tempted to plug in 1, but when you're plugging in numbers for the variables, avoid 1. Don't plug in 1, don't plug in zeros. Those are nasty numbers to plug in because they don't evolve, they do weird things. Do you understand? So the next odd number that I can think of is 3. Let's plug in 3, let's pretend t is 3. And let's just see what happens. We'll just see. I don't know what's going to happen. A says 2 times k, which is going to be 2 times 3. Now, is this quantity twice the value of an odd integer? Of course it is. You can see that. It is 2 times the value of an odd integer. So that one qualifies. That doesn't mean that the answer is A. It just means that we can't rule out A. Next one says 2k plus 3. Well, if k is 3, 2k is going to be 6. 2 times 3 plus 3 is going to be 9. Is 9 twice the value of an odd integer? The answer is no. 9 is not twice an odd integer. It's not possible to find an odd integer multiplied by 2 and get a 9. It's not going to work. So B is not the answer. Let's look at C. C says 2k plus 4. Again, 2 times 3 is 6. 6 plus 4 is 10. Is 10 twice the value of an odd integer? The answer is yes. 10 is 2 times the value of an odd integer. So C is this. So far we only ruled out B. Let's look at D. D says 4k plus 1. 2 times k to the 3 plus 1. 13. Is 13 twice an odd integer? The answer is no, because if something is twice an odd integer, it would have to be an even integer. 13 is not it. D is not the answer. Let's look at E. 4 times k plus 2. 4 times 3, which is 12, plus 2 is 14. And 14 can be written as 2 times an odd integer. So the answer could also be E. As you can see, plugging in an odd number did not get us too far, but we did eliminate 2 answer choices. Now let's try the even one. Let's see what happens. Let's try the even one. So we don't have to worry about B because B is already out. We don't have to worry about D, which is already out. Let's try A again, and this time we're going to plug in even number. Let's pretend that T is 2. If T is 2, then 2 times 2 is 4. Can we write 4 as 2 times an odd integer? The answer is no. 4 cannot be written as 2 times an odd integer. How about this guy here? 2 times 2, which is 4, plus 4 is 8. Can we write 8 as 2 times an odd integer? No. 8 cannot be written as 2 times an odd integer. The answer is not C. Answer is not A. Answer is E, because E says 4k, which is 4 times 2 plus 2. 4 times 2 is 8. 8 plus 2 is 10. And 10 can be written as 2 times 5. E is the only answer choice that can be written as 2 times an odd integer under both circumstances, under both scenarios. We have to cover our bases because we do not know. All we know is the integer is. All we know is that the integer in question is positive. We have no way of knowing if the integer is an even or odd. So we have to do both of the scenarios, eliminate the impossible answers until we get down to only one. The answer is E. This was one way of doing it. Another way for us to have taken care of this problem is to do it purely theoretically. Purely theoretically. Let's do that now. We now will do the same problem in a very academic way. That is, without plugging in numbers, just by the thought process. Let's see what happens. Okay, we have to start from scratch. We have to start from scratch as if we have not done any work at all, because we are doing a new approach. So we are told that k is a positive integer. K is a positive integer. It doesn't matter whether k is even or odd in this scenario, because in theoretical case it's just all we are working with is the knowledge that it is an, did I say an odd integer? I mean to say positive integer. All we are working with is the knowledge that it is a positive integer. We're not assuming that it's odd or even. We're not making any such assumption. If k is a positive integer, then 2 times k will have to be even, regardless of whether there is no I here, whether k is even or odd. It doesn't matter whether k is even or odd, it doesn't matter, because if k happens to be 3 times 2 is 6, and if k happens to be 4 times 2 is 8, in either case 2 times an integer would have to be even, because 2 is an even number, so even number times an odd number or even number times even number is an even number. You with me so far? Okay, so if k is an integer, then 2 times k will have to be even, and that in turn implies that 2 times k plus 1 will be odd for sure, because whatever this guy is even, and if it's an even number and if you add 1 to it, it will become odd. And now we are looking for a quantity that is twice this amount. We are looking for a quantity that is twice 2k plus 1. Well, that's pretty straightforward. It's just 2 times 2k plus 1, or 4k plus 2, which is our answer choice E. Answer choice E says 4k plus 2. And there you have it. So this is the theoretical way of doing it, as I said, algebraic way of doing it, without plugging in numbers. One more time, what we did is, I'm going to quickly summarize what we did. What we did is, we were working with the knowledge, not the assumption. We are working with the knowledge because we are told that k is a positive integer. We are not assuming that k is positive. We are not assuming that k is even or odd. We are not making any such assumption. All we are working with is the knowledge that is an integer. If k is an integer, then 2 times k would have to be even, regardless of whether k is even or odd. 2 times k would have to be even. But if 2 times k we know for a fact is even, then 2 times k plus 1 will have to be odd. And we are looking for twice that quantity. Twice that quantity is just this, 4k plus 2. That's it. We are done. I will see you tomorrow, where we'll begin the very last section of this exam, the very last section of the very last exam. I'll see you tomorrow, okay? Bye now.